Okay, so this problem is about a point whose radius vector, or the vector joining the origin to the particle's location at any given time, is basically given. So it's given in terms of this I and j. Okay, so let's read it from the start. So radius vector of a point A relative to the origin varies with time as r equal to at I cap minus bt square j cap. So this I cap and j cap are basically, okay, they're already the unit vectors. Sorry, yeah. So they are basically the unit vectors of the x and the y axis, right? So that is what I cap and j cap represents. So basically they are the x and y components of the radius vector. A and b are positive constants. I and j we already discussed just now. Okay, fine. Now we need to find out first of all the equation of the point's trajectory y of x. That is, we need to write y in terms of x. Here basically this is y, this, sorry, if you like, whatever is multiplied to j cap is basically y, and whatever is multiplied to I cap, whatever is multiplied to j cap is y, and whatever is multiplied to I cap is x. Okay, so they need the equation, I mean y in terms of x, and okay, plot this function. Fine. Next is the time dependence of the velocity v and acceleration w vectors, as well as the moduli of these quantities. Fine. The time dependence of the angle alpha between the vectors w and v. Once we get w and v, we can get the angle. The mean velocity vector averaged over the first t seconds of the motion. Okay, so mean velocity vector and the modulus of this vector. Okay, fine. So okay, let's start. So first of all, for everything we'll just copy down what is r. Nothing but r equal to at I cap minus bt square j cap, right? We need to, first of all, what is x, what is y in terms of t. So x, okay, so see, x is nothing but the x component is basically r, the dot product of that with I cap. Okay, right? So the dot, so I cap is a unit vector in the x axis direction. So if you do a dot product with a unit vector, it gives you the component of that vector in the direction of the unit vector. So we are basically getting the component of r in the direction of I cap, which is the x axis direction, which is basically the x axis component of r. So what is r dot I cap? Only, so I cap dot j cap is 0, which is really important to know. I cap dot j cap is equal to 0 because they are orthogonal vectors. So this particular problem requires a little bit of prerequisites regarding the vector space and dot products. It's better if you just revisit those concepts and you'll be able to better understand this problem. So x equal to r dot I cap, so that just gives me the first part, which is 80. Now similarly, y is equal to r dot j cap, right? Sorry, let me write that properly. And sorry, r dot j cap, which gives me minus bt square. Okay, you have x, you have y in terms of t. So now it's very easy. Now what you do is, from the first equation you can see t is equal to x by a, right? Now substitute that here. This becomes y equal to minus b times t square is x by a whole square, right? Okay, so this becomes okay, so this becomes y is equal to minus x square b by minus x square b by a square. So y is equal to minus x square b by a square. Simple. Okay, first part's done. Now yeah, of course you can plot this. So obviously it will be like um, so basically it is nothing but, so y is equal to kx square, so that is basically a parabola, and since b and a are positive constants, this will be a parabola that is curve, I mean the that is upside down basically. So it will be like something like, so let's say this is your x, this is your y, so it will be something like this. The shape will be something like this. Okay, this is how it will be. This will be your y equal to minus x square b by a square. So the y is always negative, basically speaking. Sorry. So your y in this case is always negative. Yes, this is what it will be. Okay. And of course, okay, one thing which is essential to understand in this curve also, key x is equal to 80. Okay, so remember one thing, time obviously is positive. So basically we won't have this part because x is positive. So if I just take that into consideration and redraw my final curve, would just be this, because x is 80, which is always positive, so we can't take negative values. And of course x can be 0 because at t equal to 0 it is 0. So yeah, this is basically final, this is the final curve, right? Okay, all right, now let's go to b part. In b part, what they have asked is time dependence of velocity v and acceleration w vectors as well as the moduli of these quantities. This is very simple. So velocity vector v is nothing but d, the rate of change of the radius vector with respect to time. Just need to substitute that. So r is nothing but 80 I cap minus bt square j cap. Okay, so obviously it's very simple to differentiate. We'll differentiate first this and then this. First term, if you differentiate, it becomes a I cap. Second term, if you differentiate with respect to t, it becomes 2b t j cap. This is your velocity vector v, and obviously the magnitude is very simple to find. Just need to do the summation, root of the square root of the summation of the squares of the x components and the y components, right? It's very simple. This will give me the x component is a, so this becomes a square, and vy is nothing but minus 2bt, right? This becomes root over a square plus 4b square t square. So this is basically the magnitude or the modulus of the velocity vector. Now what about acceleration vector? Now acceleration vector again, it's dv by dt, the rate of change of velocity vector with respect to the rate of change of velocity vector with respect to time. So it becomes d by dt of a I cap minus 2bt j cap, right? Now if you are differentiating it with respect to time. First term is a constant, so it becomes 0. Second term is just a constant multiplied by t, so it just becomes that particular constant. So it becomes minus 2b times j cap. This is your w. So as we can see, it is basically having a constant acceleration in the negative y direction, and the magnitude is also very simple. So the magnitude is nothing but, since there is only, so obviously root over 0 square plus minus 2b whole square, root over 4b square, which is 2b. So this is your magnitude. Done. So now you're done with A and B parts. C part is the time dependence of the angle alpha between vectors W and V. This is also pretty simple. So let's say these are the x and the y axis. Alright, this is the x axis, this is the y axis. Let's roughly plot V and W vectors, because we need the angle between W and V. So see, in general these problems are solved by taking the cosine product of the two vectors, basically the cosine similarity. And yeah, so after getting the, so basically the cosine similarity is nothing but the cos of the angle between the two vectors, right? So it's the dot product divided by their magnitude, divided by the product of their magnitudes. But it's always better to first of all check out if the angle can be found out in a simpler way before going on to do the dot product. So in this case, the W, first of all, the V vector is a I cap minus 2bt j cap. So the x component is positive and the y component is negative. So let's use this color for, we are using this color for velocity. So x component is positive, the y component is negative. So it will be something like this, right? So let's say this is your v vector. All right. And what about the w vector? W vector is straight away, it has a negative component. Yep, in the y direction, right? So let's present it with a red color. Okay, so this is your roughly your w vector. Okay, simple, very simple. So you have, so this is your w vector and this is your v vector. We need this angle. So let's say this, what angle have they called, have they denoted it as alpha. So we need this alpha, right? So alpha, as you can see, is nothing but, so tan alpha, if we simply see what is tan alpha. Tan alpha, so it's basically nothing but the angle between the velocity vector v and the negative y axis. That's what it is, right? So it's basically, so this distance, what is this, the x component, we already know the x component of v is a, right? And the y component of v is the y component is 2bt, the magnitude, right? So tan alpha is nothing but the height by the base, which is a by 2bt. This means alpha is equal to tan inverse a by 2bt. There you go. The much simpler way of doing it instead of going into the cosine product, cosine similarity thing, because over here the vector w is like just in the negative y direction. So the angle is very easy to find this way. So just just think before using the cosine similarity thing, because time is of the essence in solving competitive questions. Okay, now the D part is the mean velocity vector averaged over the first t seconds of motion and the modulus of this vector. This is, I think, the simplest part of all. So as you already know, the mean velocity vector, let's represent it, this is nothing but of course at any time t, it is nothing but the delta r divided by delta t. The basically the whatever is the change in the change in the radius vector divided by the time taken. Simple, right? So this is nothing but r at some time t. I'm just writing it as a function just to sort of show that it's like r at t minus r at 0 time divided by t minus 0, right? So r at t is, we already know, it is ai cap minus, sorry, it is at I cap minus bt square j cap. It is at I cap minus bt square j cap, and right, just a second, bt square, yeah. And at 0 it is nothing but 0 minus 0, yeah, and this becomes, yeah, t. This is anyways 0, the second part. The first part we just divide by t, it becomes a, it becomes a I cap, right, minus b t j cap. This is what is your average velocity vector. Done with this. Now let's find the magnitude. Nothing but root over x component square plus y component square, a square plus minus bt whole square gives me root over a square plus b square t square. Done. So we are done with all the parts, and yes, that is how to solve this question. So just one more thing I would like to repeat, that it's better if you go through the concepts, very simple concepts of basically like the how can you represent a vector in terms of the x and the y axis, basically the two-dimensional vectors, what do they basically mean, and yes, some very simple idea of dot product would be required to solve this question. So yeah, thank you.